Hello, and welcome to the lecture on regression analysis. My name is Chris Curran, and I'm an assistant professor of public policy at the UMBC School of Public Policy. In this lecture series, we're going to be talking about one of the basic tools for trying to assess the effects of policy in the absence of a randomized control trial. In the first part, we're going to revisit the problem of causal inference and motivate the need for non-experimental methods such as regression analysis. So to begin, let's imagine that we wanted to assess the effect of class size. Well, the goal would be to have two settings, or two schools, such as those pictured here, one of which has small classes and one of which has large classes. Notice that of these two schools, they only differ on one characteristic, namely the size of the class. We can think of that characteristic as the treatment, right? It's the policy or the practice that we're interested in estimating an effect of. So if we want to know what the effect of having been in a small class is, we could simply go to the school with small classes and look at outcome variables such as student achievement or graduation, and then go to the school with large classes and look at those same outcomes and see if there was any difference in the achievement levels or the graduation rates or whatever outcome we're interested in assessing. In the case that the only two things that differ between the schools are the class size, whether they're small or large, then any difference in the outcome we see has to be attributable to the difference in class size. After all, there's nothing else that varies between the two schools. We call this situation exogeneity, or we say that the treatment is exogenous. And that just means that it's not correlated with other aspects of the schooling environment or other omitted variables. So this is the goal, right? We want a situation where we have a treatment and a control, or a treatment and a comparison that only differ on one characteristic. The problem. Well, the real world is complicated. And most interventions and policies involve things like choice, or they involve requirements or levels by which schools or people qualify for the service or the intervention. And while this is nice in the real world, right, as humans we enjoy and value choice, this poses a real complication as researchers. So let's revisit our two schools. Here they are again, the school with small classes and the school with large classes. But now we have a situation that probably looks a lot more like the real world. The school with small classes might have better teachers, higher achieving peers, more motivated parents, perhaps more financial resources. The list could go on and on and on. We imagine that there's a lot of things that are different between the small class school and the large class school. So the large class school, in contrast, might have weaker teachers, lower achieving peers, perhaps less motivated parents. We now say that the treatment, class size, is endogenous. So remember, our first word was exogenous, meaning that there was nothing else correlated with the treatment. Now we have things that are correlated. So just as you see in the example, the quality of teachers, the quality of peers, the involvement of parents, these things are all correlated with class size. Well, what does this mean? Well, it means if we're trying to assess the effect of class size, simply comparing the outcomes at the small class school and the large class school will confound the effect of class size with all of these other characteristics of the school that vary. So if I go into the small class school and I see that students have higher achievement, I don't know whether that's attributable to the small class size or whether it's attributable to the teacher quality or the higher quality of peers or the more motivation and involvement of parents. I simply can't disentangle these simply by looking at the outcomes. So endogeneity is a problem. If I'm a policymaker and I want to know whether it's worth investing in small class sizes, I want to be able to isolate the actual treatment effect of class size separate from all of these other confounding variables. We've talked a little bit about the ideal, right? The ideal is essentially random assignment. You could imagine this as being like a coin flip. So in random assignment, some schools or some students experience small class size and some experience large class size. And the reason that they experience one or the other simply comes down to random chance, the equivalent of a coin flip. Notice that when you have random assignment, you take out all of the other confounding variables. You get back to that ideal situation that we set up at the beginning, where the only thing different about the two environments are the class size. So the beauty of random assignment is that it allows us to actually have a true estimate of the effect of the treatment, in this case class size. Now notice that the term random assignment is different from random sampling or random selection. Right, so previously we've talked about how we choose participants and the value of using random sampling to have generalizability. Random assignment is different. Random assignment is about how we assign individuals or schools or groups to either the treatment or the control group. So you could have a study that actually has a non-random sample. For instance, I could conduct a study only in Baltimore City schools. That's not random. Baltimore is one specific city out of the country. But I could still use random assignment if I assigned treatment and control within Baltimore City schools with the equivalent of a coin flip. So when we have random assignment, we have what's called a randomized control trial, an RCT, or you'll sometimes hear it referred to as an experiment. So the term experiment in social science research has a very specific meaning a randomized control trial, meaning random assignment. Now, the reality is, just as we've noted, not like the ideal. So random assignment is often not possible. It's hard to get stakeholders to buy into this. It's hard sometimes to feasibly do this. Sometimes you face ethical issues and so forth. So because of this, we need a series of non-experimental methods that can try to approximate a randomized control trial. In other words, we need tools that can allow us to take secondary data or data from situations where we don't have random assignment and try to parse out, to the best of our ability, the effect of the policy. So we're going to be talking about, through this lecture series, one of the most basic methods to do this, and that's OLS, which stands for Ordinary Least Squares Regression. You'll see in the chart on the right, though, that OLS regression is just the most basic kind of first step at trying to come up with causal estimates. So I've arranged this list from, at the top, randomized control trials, sort of the gold standard of causal research, to down at the bottom, OLS regression is sort of the first vanilla-flavored, naive type approach to getting causal estimates. And in between, I have a variety of approaches, some of which we'll talk about in later lectures. So this hopefully gives you a kind of framework to think about OLS regression. We've seen randomized control trials as this gold standard. We've set that up as the ideal. And now through the next series of lectures, we're going to think about how OLS regression can begin to provide us with estimates that perhaps start to approximate or get a step closer to causality. We'll also talk about, though, how limited these can be and think about some of the limitations of OLS regression. So I thank you for your time and I appreciate your attention.